Hello, my name is Mark Lindsey and I'm a technical specialist with SMC Electric. Today we are focusing on VFDs and our topic is common mode current and grounding. Common mode voltage or current is something that occurs mostly because of capacitive coupling in the motor and conductors. They are common to all the conductors, hence the name common mode. The primary currents traveling down the conductors to the motor are out of phase with each other and are what produces power in the motor. They essentially reach zero potential inside the motor, and that's the end of the story. Common mode current is the same potential on all three legs and doesn't terminate in the motor. These currents need a place to go and they want to return to their place of origin, which is the DC bus of the drive. These currents are usually smaller and acceptable in smaller motors. However, as motor size increases, so does the amount of common mode current. One of the major downsides is potential for drive failure. One of the first steps in addressing common mode current is to have adequate proper grounding. A good, solid, low impedance ground directly between the motor and the VFD is the best way to bring these currents back to the drive. If you simply ground the motor to, say, structural steel of the building and not directly to the drive, you run the risk of having these currents travel through the structure and back to the drive through the incoming power and not directly to the bus. This can potentially take out your pre-charge circuitry on the drive. In this wiring scenario, we have the motor. They have taken the ground and simply tied it to the system ground or structural steel. So the common mode current and voltage that ends up in the motor comes through ground into your system ground and travels through it back and potentially into your incoming power through your transformer and into your incoming power of your drive. And this is what can potentially take out the pre-charge circuitry on the drive. So in our second example that we have here, pretty much the same wiring scenario, but we've not only have tied the motor to the structural steel, we have a dedicated wire from ground directly back to the drive on the PE connection. We still take another one of the PE connections and tie it to the panel ground. But in this case, the common mode current that is generated out in the motor will take the path of least resistance, which is this piece of copper ground wire that goes from the motor back to the drive. And that is the shortest path, and it will avoid the common mode current from going through the incoming power. Keep in mind that Allen Bradley 750 series drives have jumpers that allow you to disconnect or connect the drive's capacitor bus common to the PE connection of the drive. PEA ties the incoming power to ground through MOVs and capacitors, while PEB ties the DC bus common to ground. Most industries in America use a solidly grounded electrical system, and you want to ensure that both the PEA and PEB jumpers are installed in this grounding scenario. For the 750 series drives, PEA and PEB locations can be found in the 750 series AC drives installation instructions or the PowerFlex 750 series power jumper installation instructions. We will have both of these links tied to this video. Another problem with common mode current is the possibility of motor bearing failure. The first step is to reduce the amount of common mode current as much as possible. Common mode chokes can help with this. The use of grounding rings and insulated bearings are additional steps that can extend the life of your motor bearings. Also, you can use VFD cable, load reactors, and DVDT filters. I will cover some of these in upcoming videos, so be sure to keep your eye out for them. If you need help figuring out how to properly ground your application, contact your local drive specialist and we will be happy to assist you. Let SMC help find a solution that best fits your needs. Contact your local branch or find us online at smcelectric.com. Thank you for your time, and remember, at SMC, our knowledge is your power.